Perform and complete a full hypothesis test for proportion. Let's use the critical value approach. Lily, a nutritionist, is concerned adults are not eating breakfast, which can help with memory function during the day. She would like to test the claim that the percent of US adults who eat breakfast daily is less than 60%. She decides to complete a hypothesis test at a 5% significance level. She samples 39 US adults and determines the sample percent to be 59%. Work through the testing procedure, and interpret the results of the hypothesis test. Let's revisit those steps. So first, we're going to identify the null and alternative hypothesis. We'll then decide on the significance level. We'll compute the test statistic and use that then with the critical value to interpret the results of that hypothesis test. So let's go ahead and work through those 5 steps. First, the null and alternative hypothesis. So we know this is a left-tailed test because the alternative hypothesis would be if the percent of US adults who eat breakfast daily is less than 60. So less than is a left-tailed test. Now remember first that the null hypothesis is always the equality. So I'm going to have my null hypothesis at P, the proportion, equals 60. And because left-tailed test less than 60%, our alternative hypothesis is going to be P is less than 0.60. Let's move on to our level of significance. We are told that the hypothesis test is at a 5% significance level, so that means alpha is 0.05. To compute the test statistic, we're going to need our information. So we know that the claim is that less than 60% eat breakfast daily. The other data we are given is that we have a sample of 39 adults, and we have the sample percent to be 59. So our sample percent is 0.59. Our claim percent is 0.60, and our sample size is 39. Because we're dealing with a proportion here, we are going to be using a z-test statistic. And so we're going to write out our formula and substitute in our values. Now, one thing I highly recommend as you're working through these problems is that you write down your values. So before you get to the formula, write down what you know from your problem. And then write the formula out just in symbols before you substitute in the numbers. It's really going to help you keep things straight. Where does that 0.59 go versus the 0.60? You want to make sure you have everything organized accordingly so you don't make a silly mistake as you're working through. Now, when you plug this into your calculator, make sure you use parentheses, follow the order of operations, as well as that'll make a huge difference in getting the correct answer. So after we do the calculation here, we will find our test statistic to be negative 0.13. Great, we're going to use that here in just a moment. To find the critical value, we know that it's left-tailed, so we're just doing with a single side here, and the significance level is 0.05. So because it's left-tailed, we know our critical value is going to be negative. And because our level of significance is 0.05, we know our critical value is negative 1.645. When we interpret the results, we need to use our critical value as well as our test statistic. So for a left-tailed test, if the test statistic is less than the critical value, falls in that rejection region, that's when we know that we reject the null hypothesis. So for our case here, our test statistic, negative 0.13, is actually greater than the critical value. It's going to fall to the right, and therefore it is not going to fall in the rejection region. So we fail to reject the null hypothesis. So our interpretation of these results then say, at the 5% significance level, the data do not provide strong evidence for Lily to conclude that the percent of US adults who eat breakfast daily is less than 60%.